No questions? Okay, so what I will do today is I will discuss minor one question first and the marking scheme, and soon you will be sent all the papers. So please make sure that you understand, how is the marking scheme, and then you can return back to me if you feel like that, you have not been given marks as described in marking scheme. But please make sure, please don't come for half marks. It is not going to change your grades. So please keep that thing in mind. Okay. And second thing, that we are going to check all the questions again in that case, because there is a chance that you may have got half marks extra in other questions. So please keep that thing in mind. Uh, Questions has been checked by TA, and there can be error. So please let me know if you see that there is a major error. Uh, but please make sure that for you don't come for half marks, uh, because in other question you may have got half marks extra. So it is always like everybody is prone to error. So they may have given half marks extra in one question, half marks less in another. But you feel like that you deserve it, please come. It doesn't mean that I am saying that you should not come. Please come. If you think that question is not checked as you uh, wish, okay. But please make sure that marking is you are following marking scheme. Okay, marking scheme is decided before questions are getting checked, and so we are not going to check marking scheme. Yes, if you have not got marks according to marking scheme, that is a different issue. Okay. Okay, so let me go ahead and start discussing questions. Okay, so I will upload marking scheme for question number 1. Oh, okay, let me see. I think this will not be a good way. So just 1 minute, give 1 minute.
Excuse me, sir.
Yes, yes, बताइए.
Sir, I had been sent mail to. I was in yellow zone, so I had been sent mail to TA, but I didn't send mail to CC to you. But I send email to you within the time. It is not problem and not problem.
आप ये बताओ तुम्हारा ये ईमेल एड्रेस क्या था?
सर हैकर नाम से था सर.
ऐसे ईमेल क्यों रखते हो यार?
सर
हाँ,
वो मेरे भाई का था. मैं अपने मोबाइल से सर अपने मोबाइल से मैं कर रहा था, लेकिन मेरे मोबाइल से हो नहीं रहा था, तो इसलिए मैंने
okay,
अपने भाई के मोबाइल से
that
कर.
is okay. I will check it, but please make sure that you send through your IIT email address. ठीक है? नेक्स्ट बार से आप याद रखना. विशाल, am I right?
ओके ओके सर.
हाँ,
यस
ऐसे
सर,
ही
यस सर, ओके सर.
ईमेल रखोगे तो फिर तो कोई नहीं खोलेगा तुम्हारा ईमेल. नहीं?
यस सर.
ओके.
यस सर.
या ओके, जस्ट कीप दैट थिंग माइंड. आपका चेक हो गया होगा. So don't worry about that. Just 1 minute. Give me 1 minute time. Yes. Can you see this?
Yes, थोड़ा बड़ा खुला है.
Okay. Okay, just 1 minute. Is this okay now?
Yes, sir.
Okay. So if you remember question आपको याद है? Let me then open question also.
So बेटा क्वेश्चन हम अपने एंड में खोल लेते हैं आप मतलब
खोल लोगे? Okay, that's good. अगर तुम लोग खोल लोगे तो that is very nice. Okay, because it is taking me time. Okay, so let us go and see. The question था, there are two terms in the denominator. Okay, and so there should be at least two steps. First one should be reversible. So that point, if you can write half marks, because it was written in the question that you have to tell the rule, and that gives you half marks. And then there are two steps. That's how I showed you in the class. Even if you are in the final, you have made this thing, that's okay. That will give you 1 marks. Okay. And then concentration term of the product in denominator. So there is a concentration term of product. If you remember that there is a term D, which is a product. So it must have formed in the reversible step, one step prior to this. So this is your D. Okay, and then there is a so half marks for this also, writing this. There is a concentration term of reactant B in the denominator, so it must be reacting with I. Sorry, it must be reacting with I. So I plus B. So these two, so 1 marks for this, writing D and B, and writing these two rules. Okay. Composition of reactant in the second step, the way I explained in the class. So this will be 2A, 1B minus 1D. Can you just see that? Check the question. अशोक जी, मेरा क्लास चल रहा है, मैं करूँ आपका? ओके ओके, थैंक यू. Okay, so 2A, 1B and minus 1D. And then composition of intermediate, if you find out, then it will be 2A minus 1D. Because you see here, ये क्या था? 2A, ये B है, am I right? 2A, 1B and minus 1D the composition. 1B is already there, so what will be the composition of this I? This will be 2A minus 1D, all right? And if you do 2A minus 1D plus D, then this will be 2A. So that is how this, so reaction will start with 2A to giving you I plus D, and then I plus B give you product. Any question here?
सर नेगेटिव टर्म आ रहा था, मतलब मेरे जब मैं एटॉमिक बैलेंस कर रहा था तो उसमें मेरे डिनोमिनेटर में एक एक्स्ट्रा टर्म मुझे लग रहा था लाइक, तो एक नेगेटिव टर्म ज़्यादा आ रहा था.
आप देखो फिर से उसको. You have to ओके, लेट मी, क्वेश्चन क्या था?
सर आयरन ऑक्साइड, आयरन प्लस फेरिक ऑक्साइड प्लस आयोडाइड।
आप उसको देखो फिर से, हाँ, and you will find out that composition of reactant in the second step will be 2A 1B minus 1D.
इसमें
Okay,
माइनस वन डी को कैसे रिप्रेजेंट करेंगे?
नहीं वही बताया ना, तो इसका तुम्हारा जो I जो होगा ना 2A minus 1D होगा. It is a, you, that's why I have written this, that this is a molecule.
यस सर, यस सर।
ये A, B और D सारा molecule है.
हाँ यस सर।
Alright, so please keep that thing in mind. अब कैसे होगा, यहाँ देखो एक D निकल रहा है, तो certainly this will be 2A minus, और एक ये देखो एक B है, तो इसका कंपोजिशन क्या होगा I का? एक B ऑलरेडी यूज्ड हो गया, तो 2A minus D ही होगा ना, और 2A minus D I को रखोगे प्लस 1D करोगे तो यहाँ क्या आएगा? 2A आएगा, am I right? क्या? और तुम इसको फिर सॉल्व करके देख भी सकते हो, स्टडी स्टेट लगाओ I पे, you will get the same expression what I have given.
सर सो IA 2A माइनस D था,
हाँ?
सो I था वो 2A माइनस D था।
2A minus B नहीं आएगा, देखना अच्छे से, 2A 1B minus 1D.
ठीक है सर।
Okay, you remember that this is the rate determining step. You have to keep that thing in mind. It means this term has to be neglected before you calculate the composition of reactant.
यस सर।
Yes, आप करके देखना, वो जो B वाला टर्म है नेग्लेक्ट करो डिनोमिनेटर में, क्या था? कैन यू टेल मी द क्वेश्चन?
क्वेश्चन इज 2,
so Ka square B,
Just 1 minute. What was the question?
Ka square B upon Kb plus Kd.
K square B upon K?
Kb plus Kd.
KB plus KD. Okay. So let me write down again. So what I will do is,
So I have sent the question paper in the chat, so you can see from there also.
okay, thank you. Thank you very much. Okay, so just 1 minute. Okay, so let us see what I have written. Rate of reaction is equal to K A square B divided by K dash B plus K double dash D. Am I right? So two terms in denominator. So two steps. That's what I discussed. Am I right? D यहाँ पे है, तो ये D must have formed here, and B is reactant, so it must be here. Am I right? Now you see, if I take this step as a determining step, then I neglect this. So क्या हो गया? 2A 1B minus 1D. That should be the composition. So you need to write out composition of I. Composition of I क्या होगा? 2A 1B minus D. ओके, नाउ यहाँ पे देखो, यहाँ पे क्या था? I plus B था, ये I plus D था, ये कंपोजिशन है. अब यहाँ पे देखो, इस स्टेप में रिएक्टेंट का ये कंपोजिशन है, तो इंटरमीडिएट का कंपोजिशन क्या होगा? यू टेक आउट 1B बिकॉज देयर इज 1B हियर. So composition of intermediate will be composition of intermediate will be 2a minus d. अब यहाँ पे देखो 2a minus d plus d, यहाँ पे क्या आएगा then?
2a.
That's all. तो करके देखो इसको, फिर अपना स्टेडी स्टेट आई पे लगा के देखो वेदर यू आर गेटिंग सेम थिंग और नॉट। यहाँ पे क्या आना चाहिए, क्या था इक्वेशन टोटल?
C आना चाहिए सर।
2a plus b is
B
equal to
plus B is equals to C plus D.
c plus d, यही था ना? तो यहाँ पे c फॉर्म होगा, d already there. Is this okay?
Yes, sir.
अब फिर तुम अपने से सॉल्व करके देखो, स्टेडी स्टेट लगा के देखो, दिस मैकेनिज्म स्टेडी स्टेट व्हाट यू विल गेट, दैट इज ऑलवेज अ बेस्ट वे टू चेक व्हाट एवर यू हैव डन इज राइट और नॉट। ओके
Yes, sir.
ओके, कितने लोगों ने किया था? एनीवन?
सर यस सर सेम।
ओके, वेरी नाइस, गुड
सर बट इट वाज,
ये सब ना थोड़ा सा यही है
सर,
कि थोड़ा सा, या प्लीज
सर बट थोड़ा शुरू में थोड़ा कंफ्यूजिंग था, आपने जब बीच में थोड़ा बताया उसके बाद लाइक लगा कि डी जो है उसको मतलब कंपोजिशन ऑफ आई को फिर 2a माइनस डी लिखना पड़ेगा, क्योंकि कंपोनेंट्स तो मतलब अगर
इसीलिए मॉलिक्यूल लिखा हुआ था, बट आई जस्ट गेव बिकॉज हिंट आई गेव बिकॉज यू नो just to make it easier for you, that is the only thing. Yeah, but hint was not required. If you see that AB is a molecule, not atom, am I right? Then you see you could have just why it has not been written atom. Okay,
यस सर
is it okay? Okay,
सर मैंने वर्ड्स में लिख दिया था कि जैसे कि आई की
अब
कॉम्पोजिशन
वो अब
में
तो देखो मैंने स्कीम बता दिया है, and I am saying that any step you have written, for example 2 step also you write, then there will be a marks. So marking scheme मैंने बहुत अच्छे से बता दिया है आपको, तो कहीं पे कुछ confusion से गलती हुआ तो that I can't help, but anything, for example if you write D has been formed in the first step, that will also fetch up marks.
अच्छा नहीं सर, मैं ऐसे कह रहा था कि जैसे मैंने लिखा था कि आई में ए के ट्वाइस एटम्स हैं और उसमें से डी के एटम्स हटा दो तो वो आई बनेगा, ऐसे लिखा था।
नहीं कोई बात नहीं, we will see that. Okay, a student must have seen that. तो उनको एकदम बताया हुआ है तो कैसे आपको मार्क देना, मार्किंग स्कीम मैंने ऑलरेडी आपको दिखा दिया। Is it okay?
So just one clarification.
Yeah.
The reaction was written 3 times in the answer sheet, so I mean 3 different marks for each.
Just 1 minute. Hello. Yes, क्या बोल रहे थे तो?
सर रिएक्शन 3 बार लिखा हुआ है, मतलब एक बार तो रिवर्सिबल साइन बने हुए हैं और एक बार जो है इंटरमीडिएट करके, तो
दैट इज नॉट अ प्रॉब्लम, ओनली थिंग हियर मैं समझाने के लिए बता रहा हूँ आपको, बट यू नीड टू राइट रूल्स आल्सो बिकॉज रूल्स आल्सो गिव्स यू मार्क्स, राइट? ये मैं पहले भी लिखा हुआ था, उस समय भी बताया था, वहाँ पे साफ लिखा हुआ है कि रूल आपको लिखना है। You can write in 1 step if it is right, but if you have not, so answer may be right, but if you have not written rules, you will lose marks. Okay? Is it okay? समझ में आया? Okay. So please, yeah.
Any update about quiz? सब्जेक्टिव होगा या ऑब्जेक्टिव और कब होगा?
क्विज तो ऑब्जेक्टिव ही होगा, हाँ, और क्विज आई थिंक कि जैसे ही हमारा खत्म होगा मेरा क्लास, I will organize a quiz. Okay? So that whole course is included in that. So there will be 2 quiz, I believe. That's what Professor Kuntal Manna has told.
Yes, sir.
Yes? Yeah, please, because he is the coordinator. So he will let you know everything, how things will be done. But what I feel that we will do it at the last of the, when I am done. Okay? So please keep that thing in mind, and it will cover all the thing. It will be mostly objective or 1 mark question, or maximum 2 marks question. So it will be kind of objective. It is not like A, B, C, D option. Sometimes you have to solve also, but it is means it is a kind of objective question, 1 or 2 marks question. Okay. चलो तो सेकंड क्वेश्चन देखते हैं. Okay, so let us do this. Okay, can you see now? Okay. Okay, so this A going to B, 2A going to B. I have already discussed one of the question, A to B, how to do this. Okay. So minus dA by dt, we need to write K1A minus K minus 1B plus this will be 2K2A square minus 2K minus 2B square. Okay. So please keep that thing in mind. There should be two term here because since it has 2A going to 2B. Okay. So please keep that thing in mind. So 2K2A square minus 2K minus 2B square. This is just for writing this, you got 2 marks. But if you have missed these two twos, then you get only 1 marks. Okay. And then simple thing, minus dA equilibrium by dt, you write same thing, just in this place of this, you write A equilibrium. Okay. And also, please, just 1 minute to tell you that this, if you have written this, this is not valid. I have discussed before that also that if A is going two different reactions or A going to B and B going to C, then things will be different. You cannot simply write K1A equilibrium is K minus 1 equilibrium. Basically, this is equal to 0. Minus dA equilibrium by dt, this equation is equal to 0. So just to remind you. Okay, and then you just subtract it. It is quite simple. Same way you have to write. And then this is A is equal to, here you see A is equal to, I have written A equilibrium minus X and B then will be X. And that is for this also, this also. So for A, you just write A equilibrium minus X. So A equilibrium minus X or A minus A equilibrium is X. So simply you can write minus K minus 1, B minus B equilibrium is equal to X. And then A square minus A equilibrium square, A equilibrium minus X square minus A equilibrium square. That you have to write similarly minus K minus 2, B equilibrium minus X square plus B equilibrium square. So you will get this term. Okay. And then you can simply differentiate it, integrate it. So this is not very difficult. The only thing is you have to write means you have to calculate basically minus dA minus A equilibrium by dt. If you do that, then you will get the answer. Okay, please keep in mind this is not this is a rough thing, but we have done it or maybe plus minus somewhere will be not right, but that has been, I think, corrected. So please keep that thing in mind. Okay, any question here? It is not very difficult question. Only thing is you need to know how to write minus dA by dt. That's all. After that, उसके बाद तो सब हो जाता है. Simply you have to subtract it, and then you know what is a square minus a equilibrium square. So just you have to do it, and so that you have kind of this kind of equation. Okay, that's what I told you to calculate, and that's what you will get. Okay. So next question number 3. Question number 3 was easiest one. Okay. So please see this. This is the question number 3. So same way, I have to write minus dA by dt is equal to k1 AB minus k minus 1 ID. Okay, and then di by dt you just write. So that makes this 0. So on I you apply steady state approximation, and that gives you the value of I. So 1 marks, 1 marks, 1 mark just for writing this right. And then just put a value of I here. Just put value of I here and then solve it. And you will get that answer. So just solving just involve 1 marks. So if you have not done, somebody has done it, then they will get 1 mark. Till this point you get 4 marks. So this is the easiest one to score. Am I right? ये तो सबने बना लिया होगा. Am I right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now let us go to last question. Okay, so this is question number 4. So ये question था A plus B giving you AB and AB going to C. This is you have to calculate relaxation time. Okay, so dAB by dt You first write, then you calculate AB. What will be the AB? And then if you put the value of minus dA by dt निकालना था, इसके लिए relaxation time. And so K1 AB minus K minus 1. इसमें एक P term था. Am I right? And if you express this minus dA by dt, so finally आपको dA by dt निकालना है. And if you calculate minus dA by dt, you will get this term. Minus dA by dt is equal to this. Once you have this, then so first step to calculate dA by dt removing I, because dA by dt has intermediate term. Okay, this AB is intermediate, and you have to remove AB. If you remove AB, you will get this. And after that, it becomes simple, the way you have done for A plus B going to C, which has been discussed in the class. Okay, so let me the second page मैं दिखा देता हूँ आपको, but it is not that difficult. तो यही स्टेप था केवल कि minus dA by dt you have to calculate by removing AB, because AB is an intermediate. Okay, so ये already I have discussed this. So let me remove this. Yeah, ये पहले मैंने दिखा दिया था. And then you again calculate minus A equilibrium by dt, and then you calculate dA by dt. दोनों को subtract कर लो. Then whatever you get, this can be written in terms of delta x. So d delta x by dt is equal to this thing, and then you calculate 1 by tau will be equal to this whole value. Okay, and delta x will be given by this value. Okay, so this is the way, if you look at, only thing you have to do here is you have to first determine this whole thing minus dA by dt. After that, it simply becomes the way you have done for any relaxation time calculation. Okay, so any question here?
सर जहाँ पर आपने माइनस डी ए बाई डी टी लिखा है, यस सर, तो वहाँ मैंने पी के टर्म्स में नहीं लिखा है. मतलब मैं कुछ के एफ और के आर कुछ मान ले रहा हूँ, और लास्ट में फिर उसको मैं मतलब यहाँ लास्ट एंड पे
K1 तो है ना, के एफ के आर ये तो है ही यहाँ पे.
यस सर, ये सर जो भी है उसको मैंने कुछ मान लिया सर.
हाँ नहीं, दैट्स ओके. दैट K1 कोई लिखे, कोई KF लिखे, इट डजंट मैटर. हाँ, रेट कांस्टेंट कुछ भी लिखो, दैट इज नॉट गोइंग टू मैटर. इज दिस ओके?
सर अगर हमने लास्ट में p को सब्स्टिट्यूट किया, पहले p की वैल्यू
कोई
फाइंड
बात नहीं, योर आंसर शुड बी राइट, दैट इज द ओनली थिंग. ये तो मैं एक वे बताया है मैंने, बट देयर कैन बी अदर वेज पीपल कैन राइट. So to me it looks like that this is the easiest way, but it doesn't matter if you have come in a different way and you have solved it, that is also okay.
Okay, sir.
Okay, it should but it should be right way. ठीक है? Any question? So it was not that difficult question if you look at it. Only thing is you should have some practice. और आई थिंक मैकेनिज्म में मैंने बहुत प्रैक्टिस कराया था. मैकेनिज्म अब बताओ, मैकेनिज्म व्हेन आई एम टेलिंग यू आंसर, डज इट लुक डिफिकल्ट? पूर्वी?
No, so not that much. But उस वक्त से टाइम थोड़ा कम था तो इतना सारा सोचने में कभी
ये
कभार
प्रैक्टिस की
फंसा था.
बात है. That's what I am saying. You have to, for example, third question was quite easy. And तो उसी में एक में करना है, एक ही आवर में करना है, तो प्रैक्टिस से ही होता है. So please keep those things in mind. अभी से आप लोग प्रैक्टिस करना थोड़ा शुरू करो, because practice is very important. Right? मैंने बहुत सारा क्वेश्चन कराया था क्लास में. Anyway, what I have already done is I am giving you, for each step I am giving you marks. So even if you have not got the last answer right, you will get some marks. Okay? Vaisali?
Yes, sir.
Pritam, do you have any question?
No, sir.
Okay. Okay, so let's go and catalysis part, enzyme catalysis. Any questions if you guys have, please let me know. कोई आपके पास क्वेश्चन है? नहीं क्वेश्चन है? Okay. So then let's go and discuss enzyme kinetics. I'm going a bit slow, so okay. Can you see now?
Yes, sir.
Yeah. So look at it. This is what we talked about, the mechanism that enzyme first reacts with substrate to give it ES complex, and then ES gives you product plus E, and that goes according to what has been observed experimentally, that there are two terms in the denominator and there is one S term. Okay. If you just go by simple, if you try to just write them in the terms of concentration of E and concentration of S at a given time, this term should not be there, but this is what you have observed, and that is when S is taken in excess, and that I have discussed, and this is the initial concentration, so you can also write S naught here. So once you do that, you try to get the rate of reaction, you will get this rate of reaction K2 E naught into S, and this quantity plus S. And this quantity we have already discussed, that is equal to Km, which is a dissociation constant. Dissociation constant for this reaction, you can say equilibrium constant of ES going to E plus S. So it talks about affinity also. Okay. So Km is high, it means affinity of enzyme for a substrate is low. If Km is low, then enzyme has a very great affinity for substrate. So this is the value of Km. Then we have also discussed about what is the K2, what is the importance of K2, and what is the importance of K2 by Km. So these three things are very important when you are dealing with enzyme kinetics. Km, K2, and K2 by Km. K2 gives you turnover number, K2 by Km gives you a specificity of an enzyme for different substrate. Okay, and I also discussed that when Km is quite less than S, then substrate is in excess. In that case, V will be constant, and then V will be also equal to V max. And if I put it here, then Km can be neglected and S cancels out. So it is K2 E naught, that should be equal to V max. So sometime we also write this is V is equal to V max into S by Km plus S. where Vmax is K2 into E2. And then again we showed that if Km is quite greater than S, then you have this term V is equal to K2 E naught S by K. This is very important equation because that tells you if about enzyme specificity towards the substrate. So enzyme specificity towards the substrate depends on K2 by Km value. So what does that mean? If you take two substrate and you take same enzyme, equal concentration of substrate, still rate constant may be different and it will depend on value by K2 by Km. So K2 by Km of a particular substrate is high, it means V will be higher, and in that case enzyme should have more affinity for a given for that substrate. Okay, so these are three very important numbers. Then I discussed about that K2 is generally written as Kcat, and again Kcat is your turnover number. Why we do write, and that I explained in the last lecture. So before going, so there are three important things which we discussed: Km, K2 and K2 by Km. So please just go ahead and think about how to define Km. And that I also discussed that when I take V is equal to Vmax by 2, Km will be equal to substrate concentration. What does that mean is that if you have got this kind of graph, then if you take V is equal to Vmax by 2, so you know what is Vmax, and then you take Vmax by 2, corresponding substrate concentration will be equal to K. This I have already discussed, so I'm not going to discuss in detail, but just I am going to repeat it because this is very important. These few parameters are very important. So again, this equation is this. So what now we are trying to do is, can we express this in terms of a straight line, and so that we can get the value of Km and Vmax. We can get it with the help of what is known as Lineweaver-Burke equation, and the way it has been done is Vmax by V is Km plus S by S, and Km by S plus 1. And so if I just take 1 by V is equal to 1 by Vmax, Km by S plus 1 by Vmax. So if I plot 1 by V versus 1 by S, I will get a straight line with slope equal to Km by S, intercept equal to 1 by Vmax. And this is known as Lineweaver-Burke equation. So there are two different kind of graphs, you know. This is simply V versus S, and this is your 1 by V versus 1 by S. So Lineweaver-Burke is 1 by V versus 1 by S. Good thing is you will get a straight line, and a straight line will give you value of both Km and Vmax. So you see here the intercept is 1 by Vmax and slope is Km by Vmax. So if I take slope by intercept, so then I will get the value of Km, and so binding affinity or dissociation constant can be known. And if Km is high, then it has low binding affinity. Enzyme has low affinity for substrate. If Km is low, then enzyme has higher affinity for substrate. Okay, then I discussed about turnover number. K2 is equal to Vmax by E naught. This is your, we know that Vmax is K2 into E naught. So K2 is Vmax by E naught, it turnover number. It is maximum number. Vmax is what? Minus dP by dt. So maximum number of product form, since this is a Vmax, number of product form per second, because this is a rate per enzyme molecule. So this is how turnover number is decided. And then a specificity constant, already I have discussed that at at lower substrate concentration Km, this S can be neglected, and then you have a K2 by Km E naught S. So for two substrate S1, S2, you can know that what is the enzyme efficiency by looking at the rate of reaction. Okay, so one thing which I discussed last time is yes. So yeah. So why we sometime write Kcat, not K2. This I will explain here. that this is the simplest mechanism which we can propose, that but the mechanism can have more steps, because if there are two terms in denominator, there can be more than two steps. Minimum number of steps is 2. So one of the example you can see here is E plus S giving you ES, ES giving you ES dash. There is another intermediate which you can say I2, then I2 going to P plus E. If you have this kind of mechanism, again you will get two terms in the denominator. Okay, so des by es is dash by dt, if you apply here on es dash, if you apply the steady state approximation, you will get k2 into es is equal to k3 into es dash. And then dp by dt is k3 into es dash, and just we proved that k3 in es dash is equal to k2 into es. So k2 into es, then you apply steady state approximation on es, then des by dt, this should be equal to 0, and you can see that now es is a function of not only e0 and s. There is like means not only k1 k minus 1, but k1 k minus 1 k2 and k3. And if I try to write this is the equation which I will get. Es is this, or A2 is equal to K2 E naught S divided by this. Good thing is that although this expression is different, we don't have to think much, because what is changing only is the value of kcat and km, but kcat and km has the same significance. Okay. Now, what is the kcat? Kcat is simply k2 into divided by 1 plus k2 by k3. So, in the earlier case, it was simply k2, but now it is k2 by 1 plus k2 by k3. And km is k minus 1 plus k2, k1 1 plus k2 by k3, rather than simply k minus 1 plus k2 by k. So that is the only difference, but significance of km and kcat remains same. So it doesn't matter whether it goes by 2 step or 3 step, kcat will serve same purpose. So generally we don't write k2, we write kcat when we are dealing with line means enzyme kinetics. And km, again, it is a dissociation constant, but its value now will be different. Okay. Okay. Now next question is, so enzyme inhibition is another thing which is very important, because this inhibitor are generally used for designing drugs. This inhibitor can be a drug. Okay. Now think about what can be the different combination which can happen when this enzyme and substrate is present with the inhibitor. So this is the thing, enzyme plus substrate giving you enzyme substrate complex and going to P. Okay. And then I can combine with E to give you EI. Then this EI will combine with S to give ES. The second way it can go is E plus S ES. And then I can add to this ESI. So in several different way, enzyme can inhibit. So first by combining with E, and then second with combining with ES. Okay. So this so there can be a different kind of mechanism, and I will discuss one by one all the mechanism, but general mechanism like this going to be. Now question is, you see here how we will write rate of reaction for this complex thing. Only thing here, it is assumed that only ES can go to product. ESI will not go to product, EI will not go to product. Only ES can go to product when this happens, and that is what generally has been found. So there are three different kind of mechanism here: competitive, uncompetitive, and non-competitive. I will discuss in detail in the next lecture, but that can be expressed in terms of this whole scheme. Okay, so those three are special cases of this complex mechanism. Now question is how to write rate of reaction for this. So generally we start with V is equal to K2 into ES by E naught into E naught. Okay. So what is this? If you remember, what is the rate of reaction for this? K2 into ES. So dP by dt is simply K2 into ES. If you look at this mechanism, what now I am doing is I am multiplying by E naught divided by E naught. So this is K2 into E naught into ES by E naught, which is basically fraction of ES. K2 into E naught, we already know this is V max into fraction of ES. So main thing is how to calculate fraction of ES. This is very important thing. Okay. So one of the important thing here is for such kind of complex reaction, generally we apply pre-equilibrium concept. So what that mean is, in that case, we can write K1 by K minus 1, which is the equilibrium constant, is equal to ES by E into S. That we can write. And that is also possible when a fast equilibrium is followed by a slow step. And that we have discussed this. Once you apply pre-equilibrium concept, it is very easy to calculate this fraction of ES and so rate of reaction. And you can think of several different possibilities. Some of them I will discuss, but it is quite easy to calculate once you take pre-equilibrium concept. And that's why pre-equilibrium concept is also very important in kinetics, particularly enzyme kinetics. Okay. So hello. I think there was a problem. Now can you listen me?
Yes. Yes.
Yes. Okay. So can you see slide?
Yes.
Yes, sir. Yeah. So fraction of ES, how you can calculate? That is the most important part. Fraction of ES is ES divided by E plus EI plus uh, uh, ES plus EI plus ESI, because you see uh, E enzyme, total enzyme will be either in E form or ES form or EI form or ESI form. Okay. So 1 by FES is E divided by ES, ES divided by ES, which is 1, EI divided by ES, and then ESI divided by ES. Now what you do is this, you can E by ES you calculate in terms of equilibrium constant, KES. Again, these all K are dissociation constant. Please keep that thing in mind. So dissociation constant, product is E and S, reactant is ES. ESI, product is ES, I, ESI, all are dissociation constant, KI this. And now you express this in terms of substrate. So E by ES is KES by S. ESI by ES is I by KESI. So just putting that, you will get this whole term in terms of equilibrium constant. And if you go here in the next class, I will derive it again. But you see, 1 by FES is equal to 1 plus I by KESI plus 1 by S into KES plus KESI by KEI. And you will get Lineweaver-Burke equation like this. Similar kind of equation, except few equilibrium constant term will be that. And from that you can know. So this is very easy if you apply pre-equilibrium concept to get the value of V. And this form has very very important significance, because that tells you about the mechanism of the reaction. In the next class, I will discuss how to get the mechanism of the reaction from this equation. I will derive it first so that you know. Today I have gone a bit fast, but I will derive it in next class, and then I will show you the importance of this. So I will stop here. If you have any question, please let me know.
So have we assumed that the reversible reactions are, I mean, very fast, or that sort of?
Mostly reversible reactions are fast. Yeah. There may be exception, but yes. So generally, for example, water dissociation. This is a very fast reaction. Any other questions? No? Okay, so then I will stop here. In the next class, I will derive this equation, and then we will discuss about different mechanism and how by kinetics you can find out which mechanism a particular reaction follows, a particular inhibition follows. Okay? Okay, so I will stop.
Thank you, sir.